Hi everyone, welcome back to my channel. In today's episode, we are going to be looking at percentage composition. Before I start with percentage composition, I'm going to brief molecular masses. Molecular mass. Now you see, when we say molecular mass is simply the summation, or let's say molecular mass is the mass of a compound itself. And it is always the summation of the relative atomic mass of each element in that compound. Now, let's take for instance, assume I have a compound of Na2SO4. SO4. We have to find the molecular mass of this compound. How do we find the molecular mass? You see, each of these atoms itself, each of these elements in this compound have their own mass. Their masses is known as relative atomic mass. While the mass of the compound itself is known as relative molecular mass. Why do we need this? Because in finding the percentage of any element in a compound altogether, we need to know the mass of that element and also the mass of the compound itself. Now, from here, to find the molar mass of sodium sulfate, how do we find it? We know that the relative atomic mass of sodium is always equals to 23, sulfur is always equals to 32, and oxygen is equals to 16. Now, through their relative atomic masses, we can easily find the relative molecular mass, which is the RMM of this compound. How do I go about that? Now, from here, I can go like this. Sodium is Na. We have Na. We have 2 atoms of sodium, 1 atom of sulfur, and 4 atoms of oxygen. So from here, sodium multiplied by 2 plus sulfur S plus oxygen multiplied by 4. Now, from here, I know that sodium is 23. 23 times 2 plus 32 plus oxygen times 4. Oxygen times 4 is going to give rise to, okay, so oxygen is 16 times 4. I'll be having, this is 46 plus 32 plus 16 times 4 will give rise to 64. 64. So if I add all this together, I have 46 plus this, that should be 78. Now, 78 added to 64, that should be 12, 1, 7, 8. This is 142. That is 142. So the total mass of this is 142 gram. But the problem is that the molar mass of a compound is always measured in gram per mole. So the molar mass of sodium sulfate is 142 gram per mole. Now, hope we are getting all this. Yeah? Now, let's look for how can we find the percentage composition of an element in a compound. Now, please note something that at the end of this class, we are going to take a look at this question that is set in the previous year in Jamb, which is given to us that what is the percentage by mass of oxygen in Al2SO43, which is aluminium tetrahydrosulfate 6 dihydrate. This is an hydrated salt. Altogether, now we want to look at how do we find the percentage by mass of oxygen here. At the end of this class, you should be able to solve this. Now, what is percentage by mass? Percentage simply means it is the percent of an element in a compound. Altogether, now percentage by mass of any elements, in a compound is always given by this. Percentage by mass of any element is given as the relative atomic mass of the elements all over relative molecular mass RMM of the compound multiplied by 100%. Now, this is the formula for what? Percentage composition. How do we find it? Now, let's say for example now, as soon as I ask you that, calculate the percentage composition of sulfur in Na2SO4. the relative molecular mass of this is 142 gram per mole. Now, and I need to find the percentage by mass of sulfur. That means what is the percent? Because each of these things, they are not reacting in equal proportion. How together with me? So we have what? Some amount of sulfur that will be joined with sodium, with oxygen to form this compound. So what will be the percentage by mass of sulfur in this compound? That's what I want to look at. Now, from here, the first thing is that atomic mass of sulfur is 32. Note that. So percentage by mass, percentage of sulfur in this compound should be equal to mass of sulfur, which is 32, all over the relative molecular mass, which is 142, multiplied by 100%. Now, if I punch my calculator to get this, I should be having 32 multiplied by 100 divided by 142. Then I'll be having 22.54%. So the percentage of sulfur that is found in this compound is 22.54%. Now let's take a look at the question that is asked. How do we solve this question? They said, what is the percentage by mass of oxygen in aluminium tetraoxosulfate 6 dihydrate? The first thing that I need to know in this case is that what? To find the percentage by mass of oxygen in this kind of complex salts, this kind of what? Hydrated salt like this. The best thing for you is to find the total mass of oxygen in that compound. You need to know the what? The total mass of oxygen. If you check here, you notice that how many atoms of oxygen do we have here? I have, in this place here, this is 4 atoms times 3, making I have 12 atoms of oxygen here. In this place here, I have 2 atoms of oxygen. All together. Now, how do I find this? You now write like this. What's the percentage of oxygen? I'll find the relative atomic mass of oxygen. Now, what will be the relative atomic mass? Consider this place here. You know, we have oxygen equals to 0. Oxygen times 4, right? Times 3. We have oxygen, mass of oxygen times 4 times 3 plus, this one should be added to this. Oxygen times 2. We have oxygen here, we also have oxygen here. So oxygen times 4 plus oxygen times 2. So as you know that what? Oxygen is 16. 16 times 4 times 3. 16 times 4 times 3 plus 16 times 2. So in this case here, I should be having 16 times 4 times 3. That should give rise to 192 plus 16 times 2 to give rise to what? 32. So if I add this one together plus 32, I should be having 224 grams of oxygen. Now, you now find the relative molecular mass of the compound itself. But aluminium should be, atomic mass of aluminium should be equals to, let me check the past question that we used in getting this. We are not given the atomic mass of aluminium, but that should be equals to, from the question, sorry, it is 27. They give us the question. This is aluminium is 27, equals to 27. Sulfur is equals to 32, and oxygen is equals to 16. Hydrogen is equals to 1. All this is given to us in the question. So aluminium, from here we can find the what? Mass here. So Rnm should be Al2SO4. I'll be having aluminium multiplied by 2. We have 2 atoms of aluminium here. Now, this into brackets, sulfur plus oxygen times 4, everything multiplied by 3, plus 2 into brackets, this is water. That should be hydrogen times 2 plus oxygen. Now, let's insert the values. Aluminium is equal to 27. We have 27 times 2 altogether. Now, this should be plus. 27 times 2 plus sulfur and the rest. So 27 times 2, this is plus altogether. Now, I can further solve all this. Then the answer you get, multiply it by 3. I'll be having plus sulfur is 32 plus oxygen times 4, that is 16 times 4. Everything about this is times 3, plus 2 brackets. Hydrogen is 1 times 2 plus 16, close brackets. Now let's continue. 27 times 2, this is 54, plus, now, then it's 16 times 4, which is 64. 16 times 4 is 64, plus 32, that's equal to 96, times 3, we give rise to 288. This is all about this. Now, plus 2 into brackets 18. Now, we are having 54 plus 288 plus 2 times 18 should be 36. Now, if we add everything together, plus 36 plus 54, I'll be having 378 grams. We have 378 grams. Now, let's find the percentage by mass of that element we are given, which is oxygen. So, percentage by mass of oxygen in this place now, I'll use the word relative atomic mass of oxygen, which is 224, divided by the relative molecular mass of the compound, which is equals to this. Relative atomic mass of oxygen, that is percentage by mass, percentage of oxygen in that compound should be equals to 224 all over 378 times 100%. This is equals to 224 divided by 378. I'll have this times 100%, that should give rise to 59.26%. Now, that is the percentage by mass of oxygen in this compound. I hope you understand this little method. So, in your next Jamb, please, it is quite easier for you to solve all this. Thank you for watching this episode. Please don't forget to subscribe to my channel and like my video. Thank you. Meet you in the next episode.